What's up, Calculus students? Let's review Unit 5, one question from Unit 5, and then get into the new stuff. This is from an actual AP test. Unit 5 was implicit derivatives and related rates. This is where we're taking derivatives of implicit curves and with respect to x, and then with respect to t. So first question says, show that dy dx equals y over 2y minus x. Find the line or lines tangent to the curve of y equals 3. All right, cool. So we need to take the derivative of this with respect to x. The key thing is whenever you see a product, don't forget to use the product rule. And whenever you take the derivative of y, use dy dx. I use the product, derivative of x times y plus the derivative of y times x. Minus the derivative of 6, which is 0. I'm going to go ahead and throw that there. I need a positive y, so I'm going to leave y over there. I'm going to subtract the x dy dx. That equals y. I'm going to factor out the dy dx. And I have 2y minus x times, or the other way around, whatever. And then divide to solve, getting me this equation. When y is 3, well, I need to find the slope and the x-coordinate for the equation of the lines. So I'm going to go ahead and plug in 3 for y. And be able to find that x is 5. So I need my slope at 3, 5. Wait, 5, 3. It's going to be 3 over 10 minus 3, which is 7. I am not thinking straight. 3 over 6 minus 5, which is 1. So this is 3. So my equation is y minus 3 equals 3, which is the slope. End of the day, you know. All right. Find the y coordinate location where the curve has a vertical tangent. Vertical tangents will occur when your derivative is undefined. Your derivative is undefined when your denominator equals 0. So your denominator equaling 0 is when 2y minus x equals 0. And somehow we need to find the y coordinate locations. Well, this is where we take this, we solve for a variable, and we substitute it back into the original equation. So 2y equals x is solved for, and we're going to plug into the original equation. X gets replaced by 2y. So I get y squared equals 2y squared minus 6. I'm going to add 6, subtract a y squared, I get 1y squared. I get y equals plus or minus root 6. They ask you just for the y coordinate location, so that works. If you were to find the x coordinate location, since you already plugged this into your original curve, you'd have your x would be 2 root 6. It'd be 1 point, and then negative 2 root 6. That's your other point. Okay, a particle moves along the curve. Y squared equals xy minus 6 as time passes. It moves in such a way that when it arrives at the point 7, 1 dx dt equals 2. What is dy dt at this time, and what does that tell you about the motion of the particle? This is where we take our derivative with respect to time to figure out how y's are changing as time changes. As we stop a stopwatch, what is happening? We have an x, we have a y, we have a dx dt. We're trying to find dy dt. Just remember, whenever you take the derivative of y, you'll have dy dt. Whenever you take the derivative of x, you'll have dx dt. I'm going to go ahead and just start substituting everything in, and then I'll solve for dy dt in a second. Dx dt is 2, y is 1, x is 7, dy dt is what I'm trying to find. So I'll get negative 5 dy dt equals 2. I'll get dy dt equals negative 2/5. So my y must be decreasing because the derivative is negative. So if y is decreasing, my particle is moving down. Two-fifths of a units per second. Rotating the curve counterclockwise makes the bottom of the sphere. The volume of the sphere is given by that, and the surface area of the sphere is that. If we pretend the sphere is increasing in volume by 10 cubic centimeters per minute at the moment when the radius is 3 centimeters, how quickly is the surface area changing? This is a good little review. This is where we take the derivatives of equations with respect to t, and we kind of plug everything in. So we got dv dt equals 4 pi r squared dr dt. Let me just show you that if you're confused. 4/3 pi times 3r squared dr dt. The 3 and the 3 will cancel. So my volume equals my surface area times how the radius is changing. My area is changing based on 8 times pi times r times how the radius is changing. Radius is 3. I know the volume is increasing. That is how the dv dt, that is how the volume is changing. That is dv dt. dv dt equals 10. So this is 10. This is 3. So I got 9 times 4, which is 36. I'm able to solve for dr dt is 10 over 36 pi. I'm trying to find the surface area. I have r is 3. I have dr dt is 10 over 36 pi. I can start simplifying. The pi's cancel. I take away a 3, and I get 12. I'm going to divide by 2. This becomes a 4. This becomes a 6. I can do better than that. I should have divided by 4. If I divided by 4, this becomes a 2. This becomes a 3. And we get 20/3. Obviously, if it's free response, you leave it like that. And that is in squared centimeters per minute because it's an area. It's not a per minute squared. This is not a derivative of a derivative. This is just a first derivative. After a certain amount of time has elapsed, one of the particles arrives at 5,3 and veers off the path of the curve by moving straight upward at 2 units per second with no horizontal movement at all. How is the angle between the x-axis and the object changing at that moment? See the diagram below. Oh, there's no diagram. Make a diagram. You will not be using the original equation because the curve is no longer out of the path. We arrive at the point 5,3. We have the angle between the x-axis and the object right here. This is kind of the idea. The x-axis, the origin, and the object. That's the same right here. We know dy dt is 2 and dx dt is 0. We set up and have a right triangle, and we're going to use trigonometry. Since I have dy dt and dx dt, I'm going to use tangent because tangent involves y's and x's. I set up tangent of theta equals y over x. I take the derivative. Tangent of theta's derivative secant squared theta d theta dt. Y over x, use the quotient rule. Derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. What's secant squared theta? Well, secant theta is d over x. Cosine is the reciprocal. Cosine is x over d. Cool. If x is 5 and y is 3, that means 25 minus 9 is 14. D is root 14. Silly Mr. Messner. 25 plus 9 is 34. So D is root 34. All right. So secant is root 34 over 5. Secant squared is 34 over 25. dy dt is 2, x is 5, dx dt is 0, x is 5. So d theta dt equals, oh, the 25s will cancel. That's nice. 10 over 34. That's how my angle is changing in radians per second. Second part moves along the curve. It also arrives at the 0.53. It veers off the path in such a way it moves downward at a rate of 3 units per second. Well, these numbers do not align. All right. They actually don't really matter. How's the distance between the particle and the origin changing? This is another situation where we use the right triangle. 5, 3. X, Y, D. But we use the Pythagorean theorem. If X is 5 and Y is 3, D is root 34. I'm going to take the derivative with respect to T, get 2x dx dt plus 2y dy dt equals 2d dd dt. That's the derivatives of those. The 2's will be able to cancel. We have an xyd, a dy dt, and a dx dt. X 5 dx dt 2 y 3 dy dt negative 3 d root 34 d d dt. I'm trying to find. This is 10 minus 9, so this is 1 over root 34. So the distance is increasing because d dt is positive. D is increasing because d dt is positive. Cool. All right, that's unit 5 review. Hopefully it's coming back to you. This was our first free response unit. So it's been showing up more and more often on the AP exam. These implicit derivative questions. It used to be like all second semester material was on the AP exam. Now we've shifted to more first semester material. We got R1, R2, R3 is contained by the graphs of x equals negative 1, x equals 2, y equals negative 2, y equals 8, y equals 2x plus 4, y equals x cubed. Fantastic. Find the area of R1 using geometry. All right, cool. I need to find this point here. X is negative 1. This is 2. This is going to be negative 1 comma 8. So this is a length of 6. This is x equals 2. So this is 2, 8. So this is a length of 3. This is not to scale. So the area of R1 is 1/2, 6, 3. So that's going to be 9. Cool. Now, we are going to accumulate some rectangles. Okay, here's a rectangle. It is a representative rectangle of the infinite amount of rectangles. Its height at a certain x value will always be determined by the y coordinate at the top of 8 minus the y coordinate at the bottom, which is 2x plus 4. So depending on the x, the y coordinate will be 2 times x plus 4, giving me a height equation for the first guy, which I'll write down as h1 as 4 minus 2x. So if I accumulate from negative 1 to 2, h1, I should get 9. Now let's go ahead and over here have super h1, because I don't have a calculator, and understand I get 4x minus x squared plus c. So I need super h1 of 2 minus super h1 of negative 1. And I'm going to get 8 minus 4 and negative 4 minus 1. So I get 4 and negative 5. And there you go. 4 minus negative 5 is 9. Find the area of R2 the only way possible. Okay, so for R2, let's use a different color here. Here's a representative rectangle whose height at an x value will be given to me by 2x plus 4 minus x cubed. That's gross. This is h2. Now, can't really simplify this, so it works out. Remember, we want to sum up from a x equals left to an x equals right. We like to go from left to right. A height times a width. The height will be h2. h2, we said, is 2x plus 4 minus x cubed, which means if I want to do super h2 of x2 minus super h2 of negative 1, I'll have to find super h2. There's a plus c, it'll go away. I get 4 plus 4 minus 4. 2, 4, 8, 16 divided by 4 is 4. Cool, so that's 4. And then super h2 of negative 1 will be 1 plus 4 minus a fourth. Now, just remember that if you are doing a free response question, you can leave your answer completely unsimplified. So you could say it's 4 minus, and you could literally say 1 plus 4 minus a fourth. We're very good at doing that. I think we've been trained that we could do that. I'm going to go ahead and get the answer as well, because I'm going to check my answers and make sure I'm correct. This is 5 minus a fourth. So that's 20. So that's 19 fourths. This is 16 fourths. That can't be right. This is 8. No, this is just 4. I've got 4x. So this is an 8. So this is 8. This is not that. Also, you just prepare for to be able to use our calculator. So this is -3, which is -12 fourths, plus a fourth is -11 fourths. So this is 32 fourths, 43 fourths. I'm gonna get out Desmos because it is nice to see. If I have a height that equals 2x plus 4 minus x cubed, and if I accumulate that height from -1 to 2, I get 43 fourths. Oh no. 32 fourths. What went wrong? 4 plus 8 plus minus. It's minus. Okay, it's plus. It's minus. Now, just really quickly, you could show them as two different functions. You could put y's in them if you want to. So you could say y equals 2x plus 4. You could say y equals x cubed. You want to see the region. You got x equals -1. You got x equals 2. There's the region right there. You can see I kind of like shrunk it down a little bit. You could say your height is f of x minus g of x. You can see how your heights are positive, which is great. You can see how your height is a 0 at the end. This is great. This is a good thing to see. Your heights, making sure your heights are positive. You can integrate from -1 to 2 your heights times your widths to get your area of the region. Great. So just showing you how you do that with a calculator. R3, we got this region, a representative rectangle. We're summing them up. Their heights times the width. The width is a small x distance. The widths of all of these are a small x distance. The widths of all of these are a small x distance. The heights here, this is H3, is going to be the top minus the bottom. That'll be minus -2 or +2. Depending on the x value, the height will always be the y at the top minus the y at the bottom. So we will sum up from -1 to H3, h3 is x cubed plus 2. We do want super h of 3, h3 of 2 minus super h3 of -1. Super h of 3 is 1/4 x to the 4th plus 2x plus c. Add 2 is 4 plus 8 plus c, so that's going to be 12. C won't matter. Super h3 of -1 is 1/4 minus 2. That's minus 7/4. Get 48 plus 7/4. 55/4. That's our answer. Just double check that. If I included also, I don't know, k of x equals -2. And if I say h2 is f of x minus k of x, you can see no, g of x minus k of x. All the heights are positive. They really look just like that. And if I accumulate h3, get 9.75, which is 55/4. What the heck is going on? This is 4. Oh, I'm being so sloppy. 2 times 2 is 4. This is 8. This is 32 plus 7, 39. That feels right. All right. Okay. So don't make so many mistakes like I'm making, and you'll be fine. Glad I'm checking my answers. I kind of checked the first one, so I'm not going to do the first one again. Now, we are going to split regions in half. The idea behind this is that there is a line out there. The line is at sum x equals k. And we know that the area to the left of the line will be the same as the area to the right of the line. We already know what the area to the left of the line and the right of the line are supposed to be because we know the overall area, so we're just going to split it in half. This is when we set up an integral equation that we then solve by using super h, where we want the integral from -1 to k of h1 make sure I'm in performance mode. Okay. So if I sum up from -1 to k, my heights times my widths, I should get half of my area, or 9 halves. Well, that means super H of k minus super H of -1 will equal this. I'll be able to set up and solve an equation for k. Super H1 was 4x minus x squared. No, it wasn't. Oh, it was. 4 minus 2x. Oh, I got super H. Oh, yeah. 4x minus x squared. Yeah, I'm not going to solve this. That's fun. So H1 was equal to 4 minus 2x. So super H1 was 4x minus x squared. So if I do super H of k, it's 4k minus k squared minus super H of 1. I did this is -4 minus 1, which is -5. So I got minus -5. Yeah. This has to equal 9/2. I don't think I'm going to solve this. Two numbers that multiply to get 19 halves and add to get 4. I don't want to do that. We need to somehow solve this equation. How do you solve an equation that you don't know how to solve? You can use Desmos. You can set the equations equal to each other and find the intersection. So my bad, guys. I really thought you would be able to do this without a calculator, but you have to solve this with a calculator. Should be subtracting. Making a lot of mistakes.
Go walking around. Love it, man.
Okay, so there's two values. We only want one of them. We're talking about in between our interval, -1 and 2. So even though there looks to be two solutions, we only want the one that makes sense, and that's this value here. K equals -0.121. I thought that would be a lot easier. 0.121. It's pretty cool though how that's going to be such a unique number. Like, let me save this as A. I'll show you. The top was h of x was 4 minus 2x. If I accumulate from -1 to A, h of x, I get 4.5. Crazy. And then A to 2, I get 4.5. So it's a little off because this is a little off. There you go. So I'm sorry, but you have to actually use Desmos to solve this. Region 3. Apparently, I'm not supposed to use Desmos. Let's see. We have the area is 39 fourths. We have h is x cubed plus 2. Let's write all this stuff down. h3 was x cubed plus 2. Super h3 is 1/4 x to the fourth plus 2x. This is not going to work. Plus c. We'll have to do that. We know that if I accumulate from -1 to k, good to see you, bud. -1 to k, we'll get half the area. That's 39/8. Well, that means super h of k, which is 1/4 k to the fourth plus 2k, minus super h of -1, which is whatever it is, will give me 39/8. This is something I have to do, like without a calculator, is I have to set this up. And then solve using my calculator. So I'm going to graph y equals 1/4 k to the fourth. You could use x's. Plus 2k. Actually, I love using k's. Minus 1/4 minus 2. That equals 39/8. I have two intersections. One falls in my interval, and that's at 1.2537. So that's my answer. Solve using Desmos. Why did I think this would be solvable without? Y equals the left side, y equals the right side. What was the intersection? Solve that, save that. Let's make sure we check it. Let's call it an A. 7. Okay. Let's make sure it's correct. H was x cubed plus 2. If I accumulate from -1 to A, H3, I should get the same thing as if I accumulate from A to 2, H3. Yep, look at that. We got it. So we split the area evenly by finding this crazy value. We have to find this crazy value using your calculator. And this one we definitely have to use Desmos. All right, so for the third region, the second region, we got 45/4, which means split that in half, I get 45/8. So if I sum up from -1 to k, regular H3, I should get 45/8. I need super H3 at k minus super H3 at -1 to get 45/8. Super H, this is 2. Regular H is 2x plus 4 minus x cubed. This is 2, region 2. And regular H was top minus bottom, 2x plus 4 minus x cubed. Super H, x squared plus 4x minus 1/4 x to the fourth. So I'll get k squared plus 4k minus 1/4 k to the fourth minus, I'm just going to make this super dirty, negative 1 squared plus 4 times negative 1 minus a fourth times negative 1 to the fourth. That has to equal 45/8. Y equals k squared. K squared plus 4k minus 1/4 k to the fourth minus negative 1 squared plus 4 times negative 1 minus a fourth times negative 1 to the fourth. Obviously, you could simplify this, but let's say you hate simplifying. And y equals 45/8. We got two values. One value is in my interval, one value is out. There's my value here. I'll call this A. Just gonna double check with H2, which was 2x plus 4 minus x cubed. And if I accumulated H2 from negative 1 to A, H2 heights times widths, I should get the same as if I accumulated from A to 2, H2. There you go. Okay. An expression with an absolute value and the equivalent expression without an absolute value for the area shown. So you can say you got two heights. This height is going to be g of x minus f of x. And then this height is f of x minus g of x. However, the absolute value of h1 equals the absolute value of h2. Like, if you want your heights to be positive, you can use an absolute value. So what I'm asking you to do is to understand you can use h1 from A to B, but make sure you switch to h2 from B to C. Or you could go A to C and just make sure that you use an absolute value to make sure you have positive heights, which is going to be the same as if you go from A to C and you took the absolute value of H2. Because if you use an absolute value, H1 absolute value equals a positive H2 here. Here, H2's absolute value would equal a positive H1. So we can use either of the other. What happens if I don't give you the x equals start and the x equals end? You need to find the intersections. Well, so I'm going to take the two equations and set them equal to each other. I get x plus 5, x minus 1. I'll get x equals negative 5 and positive 1. Now I know my region is this opening up x squared and a line. I can see that my heights are a top minus bottom, which is the line, minus the equation. So I got h of x, which is negative 4x minus x squared minus 5. Now you got to subtract that entire bottom, and I can see a lot of us making mistakes at this. So that becomes negative 4x minus x squared plus 5. We can put this in the other order if we want to. I would love to accumulate this from negative 5 to 1, these heights. times their skinny widths. I need super h of 1 minus super h of negative 5. Super h, and I'm not going to simplify this. Super h of 1 is negative 2 minus 1/3 plus 5. Super h of negative 5 is negative 2 times negative 5 squared minus 1/3 times negative 5 cubed plus 5 times negative 5. Good. Done. Checking this with the calculator really quickly. It's top. We got the bottom. See the region. Intersects at negative 5, intersects at 1. Cool. We have heights, which need to be positive, which is our top, minus our bottom, f of x minus g of x. See those. Minus f of x. It's about the same. Now we got those positive heights. We have a 0 height here at the intersection. We have a 0 height here at the intersection at 5. We would like to accumulate from negative 5 to 1 h of x times the width dx, and I get 36. Are you kidding me? That's a joke, right? Let's see. If I type this stuff in, I should get 36. I mean, I could say we have super h. And I could say it's equal to negative 2x squared minus 1/3 x cubed plus 5x. And I could say what is super h of 1 minus super h of negative 5. It's a lot. It's like a little bit less to type in. Notice that it won't grab super h of x if you have regular h of x. You have to come up with super h. It does not know how to do antiderivatives. It just can calculate. It's a calculator. Okay. This one, y equals x and y equals negative x squared, it's going to look something like that. We can see that the top and the bottom is going to be the quadratic, and the bottom is the x. So h of x equals 3 plus 2x minus x squared. Okay, cool. Let's find the intersection, though. When does this equal this? I'm going to move everything onto the right side. And I'm going to factor this. And again, x equals negative 3 and positive 3 and negative 1. So this is going to be at positive 3. This is at negative 1. So I need to sum up my heights from negative 3 to 1. I'm going to need super h, 3x plus x squared minus 1/3 x cubed plus c. So super h of 3, just going to do this dirty, is 3 times 3 plus 3 squared minus 1/3 3 cubed minus super h of negative 1 is 3 times negative 1 plus negative 1 squared minus 1/3 times negative 1 cubed. This is sufficient, guys, okay? Don't like to stress out about simplifying it. I'm going to double check. Here the top was the quadratic. So that goes over here. It's X. Cool. Top minus bottom. G minus F. Go. Accumulate them from the intersection to the intersection is -1 to 3. Cool. 10 and 2/3 apparently will equal super H. 3x plus x squared minus 1/3 x cubed plus c, but we don't need it. And I have super H of 3 minus super H of -1. And I get 10 and 2/3. Hooray. Cool. All right, we may now use Desmos. Right. Find the area of the enclosed functions. Y equals e to the 3x and y equals 8x plus 1. So e to 3x, 8x plus 1. Let's go. What's great about this is I don't have to use a because I'm using y. I'm using f of x and g of x instead of y. Because if I use y, I'd have to distinguish them between y1 and y2, which I think I can do. So let's just do it that way. Can't really tell, but right there is the region. Okay, I need to figure out where we start and where we end, so I'm going to use that and that. This is the x at the start. I'll call this B, and I'll call this A. But obviously, A being 0, no big deal. I'll say my heights are my top, which is my line, minus my bottom. That works. Beautiful. Love it. Love it, love it, love it. I would like to accumulate these heights from A to B. Heights times widths from A to B. All right. Did I need the super H? No, don't need it. You can just say, I'm going to have H of X, which is my top minus my bottom. If you want to write this as y2 and this is y1, go for it. And you can say I got y2 minus y1, or you could do it. Yeah, that works out there. And you want to write that your intersections were at 0 and 0.57358. Seven, 3, 5, 8. And we will accumulate our heights times our widths from A to B. And that's it. You get your answer. 0.360. You don't need super H. Could you get super H and do super H of B minus super H of 0? Yes, you could. Do you have to? Not right now. You're good. All right. Let's call this y1 and y2. Actually, I'm going to go ahead and finish this because it says find the lines that split the previous area into equal regions. So I know that if I go from A to K, I am going to get half of the area. Now, I don't want that 0.360 divided by 2. I want this divided by 2. This entire integral divided by 2. I just shifted and copied it. And I have this. Cool. So I want to know that super H of K minus super H of A equals 0.3602. Now, again, A is 0, but whatever. Let's say super H. I mean, I'm going to do it this way, like we kind of did earlier. Super H is the antiderivative of H. H is y2 minus y1. Let's write that down. H of x is 8x plus 1 minus e to the 3x. Super H, x squared, 4x squared plus x. E to the 3x is antiderivative is 1/3 e to the 3x. Super H of k, I mean, I honestly could leave it like this. And I could solve. Watch. Let's do it. Super H is 4x squared plus x minus 1/3 e to the 3x. Super H of k, y equals super H of k. Yep. Super H of k minus super H of a, which is 0, or whatever. Graph that. And graph y equals half of my area. Find the intersection of those two. This is a very interesting way to do it, and I like it. Kind of want to do it this way more often. Ooh, got 3 intersections. One of them is going to be in my interval, which is between 0 and, what's b? 0.57. So it's this value right here. It's this 0.30693 value. Honestly, this is totally fine if you write it like this, and then 0.30693. As long as you have super H written down, you literally could have done it this exact way, where you can graph super H of x and then say graph y equals the left side. This is great. Graph y equals the right side, find the intersection. They have to accept this. This is great. Yeah. Let's do the other one. Sine of 2x and x. First quadrant. Boom. 0, 0. That value. We'll call that b. Heights equals my top minus my bottom. Oh man, can I do this? Shift dash puts it to an underscore. Shift dash underscore. This is me being a little bit silly, but loving it. Honestly, I'm just a little tipsy that you can do this. It's so awesome. I'm being silly now, but it's like coming from using the TI-84 graphing calculator for so long. We never did this. This is great. This is phenomenal. This is great. I want to integrate my heights times my widths. Regular H, heights times the widths. These are my heights going from 0 to b. Cool. I should have super H written down just in case I need it. Top minus bottom will be the antiderivative. It's like incredible. I'm so stupid. 94775. Heights times widths. Heights. There you go. Sine of 2x minus x. Cool. Super H is going to be the antiderivative of sine of 2x, which is negative cosine 2x times a half, right? Yeah. And then x is 1/2 x squared. Why do I need to know this? Well, what was my answer here? 0.210. Because the accumulation from 0 to k of this other h has to equal half of my first area. I guess we should call this like B2. Super h of k minus super h of 0 has to equal that. So super h is negative 1/2 cosine 2x minus 1/2 x squared. Let's hide this, hide this, hide this. So y equals super h of k minus super h of 0 has to equal y equals this divided by 2. And when do those two things intersect each other? At 0.501, which is halfway, almost halfway between 0 and 0.947. 0.501. Wow, that is phenomenal doing this with decimals. This is phenomenal, honestly. Provided you like understand that you have to write down everything. Super h of x. And again, we are graphing y equals this and y equals this to find the intersection to solve. As long as we have super h is negative 1/2 cos 2x minus 1/2 x squared. Like this is acceptable. And it's beautiful. It's beautiful how you can do it in your calculator as long as you do that. And then it's like, oh gosh. As long as you graph y equals. All right. One lesson down. 4 more to go. 3.5 more to go. Peace.